Section 2.6 is on solving systems of linear inequalities. So this means we're taking linear inequalities like we talked about in Chapter 1 and graphing more than one at a time and figuring out where their shaded regions overlap. So to solve a system of linear inequalities, you must find the order pair that satisfies both inequalities. This is done by graphing and observing the solution. Keep in mind that some systems do not have a solution, meaning their shaded areas do not overlap. A system of more than two linear inequalities can have a solution that is bounded by a set of points called a polygonal convex set. This is because these three or more lines form a shaded region of points that is a polygon of some kind, and it is convex as opposed to concave. So we'll see an example of what that looks like right here. So this first example says we want to solve the system by graphing. So we're going to take these three inequalities and graph them on one plane and see where their shaded regions overlap. So the first one, x is greater than or equal to 0. So I am looking for x values that are all greater than or equal to 0. So that's going to look like this line here and this whole region up here. Actually, all x values would be all these greater than 0. Y greater than 0 is going to be this line here and look like all of these values are where y is greater than 0. Notice now, though, in quadrant 1, these are where my my spaces or my inequalities are overlapping. So that's already a part of my solution. But I also need to take into consideration the line 2x plus y less than or equal to 4. So putting that into y equals mx plus b form is y equals negative 2x plus 4. So this line looks like 1, 2, 3, 4 is my y-intercept, and my slope is negative 2. So down 2 over 1, down 2 over 1. And I am this line here, like so. And what I need to do then is test the point 0, 0 and figure out where my shaded region is. So if I plug in 0, 0, I get 0 is less than or equal to 4, which is true, so I shade the region towards x equals 0. So what I'm looking for is this space in the center where all three of my shaded regions overlap. So you can see I've made a triangular set of points where all three regions are overlapping. And these are bounded by three vertices. This is the point 2, 0. This is the point 0, 0. And this is the point 0, 4. So those are the vertices of my polygonal convex set, and that shaded area is the solution to those three inequalities. The vertices of that polygonal convex set can then denote the maximum and minimum values of a function. So for example, we have this function f of x minus 3y, which is formed by the following four inequalities. I've rewritten them here because they didn't quite copy correctly. So here are my four inequalities. What I want to do is I want to graph these four inequalities, find the vertices of the convex set, and then look to find the maximum and minimum values of the function that they gave me here. So y is greater than or equal to 0 is all my y values greater than or equal to 0, which is likely going to be bounded by this line here. All the x values I'm looking for are between 0 and 5. So I'm looking for all x values between 0 and 1, 2, 3, 4, 5. So I'm looking for just this region here between 0 and 5. So it's going to kind of look like this. Looking for that region there. Then I am looking for this line here. When I move x over, y is less than or equal to positive x plus 2. I'm going to graph that in blue. That's going to look like a y-intercept of 2 and a slope of 1. So I'm going to look like this line here. Testing 0, 0. 0 is less than 2, which is true. So I'm shading this way. And finally, this line, moving the x over, y is less than or equal to negative x plus 6. So I'm going to have a y-intercept of 6 and a slope of negative 1. So y-intercept of 6 will be 1, 2, 3, 4, 5, 6, and a slope of negative 1, down 1, down 1, down 1, will look like this. And I'm looking for its shaded region, testing 0, 0. 0 is less than 6 is true, so I'm also shading here. So the part where all 4 shaded regions overlap is this polygonal set of points, and I'm outlining for us here and shading in all this area. So notice I've made a convex polygon bounded by 1, 2, 3, 4, 5 different lines. And I care about where are these vertices. So this vertice is the point 5, 0. This vertice is 0, 0. This vertice is 5, 1. This vertice right here is the point 2, 4. And this vertice here is the point 0, 2. So I'm going to take all 5 of these vertices and I'm going to use them to find the maximum and minimum values of this function. So we have something called the vertex theorem that says you can take the x and y values, each vertex, substitute them into the original function, and find the function's maximum and minimum values. So what we're going to do is we're going to take our function, f of xy equals 5x minus 3y, and I'm going to test my 5 vertices. So I'm going to test f of 0, 0, f of 0, 2, f of 5, 0, f of 5, 1, and one more, f of 2, 4. And I'm going to plug those values, x and y, into the function. So this is going to look like 5 times 0 minus 3 times 0 is 0. 5 times 0 minus 3 times 2 is negative 6. 5 times 5 minus 3 times 0 is 25. 5 times 5 minus 3 times 1 is 22. And 5 times 2 minus 3 times 4 is going to be negative 2. So if I'm looking for maximum and minimum values of a function, I'm looking for which point gave me the highest value and which point gave me the lowest value. So you can see the lowest value here is negative 6. That's my minimum. The highest value is 25. That's my maximum. So we can say the function had a minimum equal to negative 6 at the point 0, 2, and a maximum of 25 at the point 5, 0. So that is how we can use the vertices. The vertex theorem says the vertices of the convex polygonal set can give you the maximum minimum values of the function. So I'd like you to try this next one. You're looking for the maximum and minimum values of the function x minus y plus 2 given these 4 inequalities. So I've crossed the ones out that you had, I typed them incorrectly, so please use these 4 inequalities, graph them, find the region that they are bounded by. You should get these following vertices, and those are the max and mins you should get. So check your answers against those, and we will do more practice in class. Thanks.